All right, nice that you're all here. Very appreciated. Let's dive right in. One thing I learned giving this presentation a few times in the past is that the title slide is very often very much misunderstood, or at least say it helps people or giving people a laugh, because a lot of people actually read it as do Postgres, don't do Kubernetes, which is not how it meant. It's actually a good read, but I think it's the wrong read, because from my perspective, Postgres really loves Kubernetes, and the other way around. Kubernetes really loves Postgres. I expect that there is quite a few people in the audience already that use Postgres. There is a good chunk of people that, I guess, uses Kubernetes, and there is probably still a sizable amount of people that already use Postgres on Kubernetes. If you don't, I hope that by the end of the presentation, I actually got you to the point where, that sounds like a really good idea. I should totally do that. So a few words about me. Just say I'm Chris. I'm a developer advocate at Simplyblock. I've been with a few companies in the past. Some might be more known than others. Some people might have heard about this weird little gaming company called Ubisoft. If you heard about those, probably in the context of copy protection, but that was not what I worked on, at least. But afterwards, it's very much all about data. Hazelcast was an in-memory data grid, meaning that everything was about the actual data in memory that you could analyze, that you could share state between different instances to keep them stateless, stuff like that, right? It was all about data. Instana was all about observability. So it's still all about data, right? It's metrics, it's traces, it's spans, it's all about the combination of different services and how they work together in the whole infrastructure, stuff like that. It's all about data. Cleverbit was my own startup. We actually made hard-end software for animal husbandry, measuring like CO2 ammonia levels, trying to correlate them with like medication, and in general, trying to prevent medication from being given to the animals to make better meat quality. In general, get the animals a healthier life for at least for the time they actually live. We all know how that ends, right? But at least making their lives as good as possible while they're around. And Timescale is a time series database at or on top of Postgres. And as you can see in the picture, that is from last year. I really like that, like conference pictures. At a Timescale, I love to explain people why I think Postgres is the ultimate database for time series data. And now I'm at Simplyblock, and Simplyblock is also all about data. It's all about data storage, how you can expand storage, how you can scale storage. So there's a little bit of a red thread through my life. Even at Ubisoft, a lot of stuff in games these days is about data, is about interaction, how players interact with your games. So there's like this general thing. If you want to drop me a message, if you have questions, you see my socials, the presentation will be shared. Just feel free to drop me a line and ask your question. What I learned over the last couple of years is that you want to start a presentation with a game, making it interactive, making it fun. So for the ones that don't know what Family Thought is, it's basically a game show where two families fight against each other, trying to guess like the first answers that popped into people's minds. So the idea is we asked 100 people, what is your first thought when it comes to XYZ? For today, I thought it makes sense to have like, why shouldn't you run a database in Kubernetes? And because it's hard to do this live right now, I actually went ahead. I was nice enough to figure that out for you. So I went to Twitter and asked like, why shouldn't you run a database in Kubernetes? What do you think? Please help me. I need your help. When you do these things on Twitter, X, you have to remember one thing. When you ask a controversial question on Twitter, X, I have to get used to that. On X, always ask for a friend. It's important. Asking for a friend. It's not about you. Obviously, you would never do this. So asking for a friend is like the most important thing for those kinds of stuff. There were answers, and the answers were like, Kubernetes wasn't designed with databases in mind, which is very much true. Like when Kubernetes was designed initially, 10 years ago, we had the Kubernetes. Yeah, so 10 years ago, Kubernetes was designed for stateless systems and stateless only. But about 5 or 6 years ago, I don't want to pinpoint to the exact point in time, Kubernetes changed. People started to figure out, okay, stateless systems are nice, but they're not easy to be designed, right? So they started to integrate elements for stateful service is what they called it, right? So stateful service in general. True, databases weren't, well, thought about I guess at that point at least, maybe not like first thought, but that changed quite a bit. So if you're stuck in the past, yes, Kubernetes wasn't designed for databases. These days, that's not actually very much true. Then never run stateful workloads on Kubernetes. Okay, that's a harsh one. As I said, if you're stuck in the past, that's true, but stateful workloads aren't always just like database. It might be the first thing people think about and that pops into their minds. But in general, there's a lot of stateful services. It's really hard actually to write a fully stateless service because oftentimes you have like at least a minimal state that might be ephemeral, so it doesn't really matter if it gets lost, but you want to keep it because it makes stuff easier, makes stuff faster. So stateless services are actually very hard to do. Persistent data will kill you because it's too slow. That's a good one. And you might be true about that, but I think that very much depends on where you go in the sense of how do I store my data? This is up to you. Find a good data solution. I might be biased and say Simpliblock is a good one, but I think this very much depends on you. And there's a lot of options these days for Kubernetes. Even simple stuff like NFS or local hard disk, like local persistent storage, wouldn't say do this, or we'll get back to that later, but there's a lot of options. So I think that is not true. If you say, okay, I want to plug in a USB stick and I store my database on this USB stick via persistent volume, be my guest. Don't expect it to be fast. Nobody understands Kubernetes, and that is a really interesting one. I had to laugh really hard when I saw that specific answer, because yes and no, there is some truth to it. I'm pretty sure nobody understands Kubernetes, including the Kubernetes developers, including me. There is still a lot of things in Kubernetes that I've never used and I probably never will. I think it's a little bit like getting used to programming languages, right? You can say you're proficient in a programming language, but does that mean you know every little bit about those programming languages? No, you don't. But if you feel like you're not understanding Kubernetes at all, please don't run a database on Kubernetes. Don't run an application on Kubernetes. Please don't run Kubernetes at all. If you feel like you're not understanding anything about it, just don't use it. There's no need in your case, most probably. The next one is, what is your benefit? Databases don't need to scale, or especially auto scale. And that one kind of confused me. It feels this is a person that didn't necessarily run a database of a meaningful size. Many databases probably don't need to auto scale, but especially things where like you store user behavior, click flows, any kind of IoT data, all that kind of stuff, databases need to autoscale. And autoscaling can be a lot of things. It could be database, it could be compute, it could be storage. There's a lot of stuff. Then databases and applications should be separated, and I'm very much on par with that. I totally agree. Your database and your applications normally shouldn't run on the same nodes, and we'll see a little bit of a solution for that later on. So yes, fully agree. Is not an argument against Kubernetes. And the last one is actually something I very much agree with, not another layer of indirection and abstraction. Abstractions and indirections can be complicated. They don't have to be. They're a blessing. They're made in heaven as long as stuff happens and works, because they take away complexity. But they can be a beast from hell if stuff goes down the south or goes down the drain, and now you have to figure out where stuff is actually broken. That is really a problem. And Kubernetes doesn't make things easier using all those like extensions for Kubernetes, like service mesh and all that kind of stuff. All the things that make your life easier actually make it harder the second you have an issue and you try to figure out what is happening. So the question, I saw those answers and I was like, where do I get from here, right? Like, how do I make this work out for the presentation? I wanted to tell you about why you actually should do that and why it's a great idea. Do I have to burn in hell now? This is complicated. What am I doing? I want to go to the happy place. So how can we do this? So my first initial thought, hey, let's cheat. Cheating is good. I work for Ubisoft, so I know what I'm talking about, right? I'm a big gamer. I know exactly what I'm talking about. So that is something that a lot of the older folks in the audience might actually know. It's the so-called Konami code. It's probably the most known or most well-known cheat of all times. For the younger generation, just look it up on Wikipedia. Konami, like the gaming company, Konami code. It was a great pleasure. So now that we cheated, we can actually go to the real topic, right? So where do I get from here? Why do we want to run Postgres on Kubernetes? And I think there's a good set of reasons. And first of all, I'm a big hater of cloud vendor lock-in. I think it's a really big problem. Cloud vendors, especially hyperscalers, love to offer you all kinds of services and make them easy to integrate to lure you in. But the problem is those services might be nice and might be good for the first iteration, maybe the first couple of iterations, but at some point you're hitting the upper limit of what is possible. Those services are meant for the mainstream. They only work because they can be used by a lot of people. And a lot of people means that the second you have something special, there is a problem, right? They don't care for you anymore because you're not part of the mainstream. And specifically for databases like RDS and stuff, that can come in very fast if you use custom extensions or special extensions. Sure, like the standard extensions are all available, like PostGIS and stuff. But the second you come to something like, for example, timescale, you might have an old version, you might only have an Apache licensed version, which doesn't have all the features, stuff like that, right? You might actually have quite the issue really fast, even though you feel like you haven't outgrown the size of something like RDS. Faster time to market, decreasing cost, I think that goes, and automation, I think that goes all well hand in hand, right? If I have everything automated, if I have everything easily deployable, it's super easy to get to market fast, do a couple of iterations, see if stuff works, that decreases cost. I might actually save one or two people. That is where automation comes in. I tell Kubernetes, hey, or like whatever, I need a new Postgres cluster, it spins it up and makes sure that everything is around. That can be a single DevOps person instead of a team of database engineers. I'm sorry, I know that I'm bashing on database engineers here, but don't get me wrong, you still have a job. It's just not the boring stuff. Now you can actually look into the cool things, right? A unified deployment architecture, I think I'm a big lover of that kind of stuff. I think unified architecture makes things easy to understand. We have the databases deployed the same way as we have deployed our application, all that kind of stuff. That's why people love Terraform so much, right? Because Terraform gave you like a single tool to actually do all this kind of stuff. Somebody has to write the recipes, but it doesn't have to be you. And last but not least, I'm a big fan of read replicas. If you have a use case where this like small performance or a small lack of data through physical replication is not much of an issue. And that is probably true for a lot of IoT use cases, like my own startup, like Cleverbit. We actually had that. We used read replicas quite a lot. We got values or metrics like every 10 seconds, but we averaged them on a minute scale anyway. So it didn't really matter if there's one or two messages being lost or not lost, but not arrived on a read replica yet. So what we did is we literally just spread the query load to all nodes. Writes always went to the primary, but we had read replicas for query scale out. Okay, now that we know why we want to do this, what do I get from here? Let's get a few things out of the way, which aren't necessarily like super Postgres specific. From my perspective, the most important thing, and I can't stress this enough, enable TLS, enable data encryption at rest. You want to make sure your data is encrypted. It doesn't matter if you're like a 10 people company and you feel like everyone can have access to the database. That is not the point. The point is make sure that somebody from the outside cannot get to your data, like at all, like no way possible. There's nothing worse than a data breach. And luckily, to this day, I can say I've not been at a company, at least, while there was a data breach of any kind, which I think is good. I know this is not true for other people. I know I can imagine how embarrassing that is. The problem with a software update that basically killed all Windows systems just a few weeks ago, right? If you're on Kubernetes, use Kubernetes secrets, use the certificate manager, certman or cert manager, use the integration from cloud providers for credential management, all that kind of stuff. just make sure you have security locked down as much as possible. Yay! We actually got security, right? Yoo-hoo! Okay. The other thing, think about backups are important. And when I talk about backups, I don't just mean a stupid PG dump. Don't do this. From my perspective, PG dump is not designed as a backup solution. PG-based backup is okay, but please don't try to roll your own solution. When we talk about backups in Postgres, we specifically, or in most databases, we specifically mean continuous backup, meaning that the actual write-ahead log needs to be stored, same as a database snapshot. And there's great tools for that, where in the Postgres ecosystem, everything has 10+1 tools, because the Postgres distribution doesn't give you those things. So everyone started to build their own. I actually have amazing experience with PG Backrest. It is the tool that we used quite a lot. It's, from my perspective, rock solid. I know a lot of people actually using Barman, and that just works as well. There's PG Horde, and there's so many other tools. My recommendation would be either go with Barman or PG Backrest and just use. Most tools are industry proven, rock solid. They are proven. They just work. From my perspective, that is the way to go, and store your data somewhere that is not your own nodes. Don't store them somewhere in the nodes, right? Don't set up a min.io on Kubernetes and say, oh, I have an S3 API, so I can just store my backups there. That's not how a backup works. Store it to object storage like S3 or Cloud Store or Blob storage or whatever. Just make sure they're not on your nodes. And the other thing is test your backups. Please, I can't stress this enough. Test your backups. And backup testing doesn't mean like once a year or once in a while. Test it regularly, like once a month, once a week, once every day. With my own startup, we actually went for like once every week. And the way we did it, and I think Kubernetes made this very simple for us. We had a Kubernetes backup, Kubernetes cluster, and the cluster was basically one primary, two read replicas. So what we did is we just scaled the cluster up and said, hey, we need a third read replica, basically a 4-node cluster. It restored it from the backup. The nodes tried to join the cluster, so it had to set up physical replication, streamed in the remaining stuff that was not in the backup, and eventually joined the cluster. The second it had the cluster fully joined and was able to service requests, we knew that our backup strategy actually worked. We scaled it down again, and Kubernetes just deleted the oldest node, whatever that was, basically. So we had a little bit of a rolling restart system as well, which tested a few other things like cluster health and stuff like that. So I think Kubernetes makes those things like very easy and very nice to use. The other thing that kind of surprised me initially when I started using Postgres or setting up Postgres on Kubernetes is that the actual Postgres configuration isn't much influenced at all. You still want to configure like your shared buffers, workman, blah, 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 right? All of these standard parameters you're actually changing normally, but that doesn't mean that they are influenced by how you set up Kubernetes or how you set up Postgres on Kubernetes. You need to remember that you have a container and your container has like certain size limits. So you want to make sure that you're actually configuring based on that, but that's about it. The other thing is if you have no idea about those parameters, they're very much, those are the easy ones. There's like way more advanced ones, worker sizes or worker numbers and stuff like that. If you don't feel like you have a good idea what they mean and how they affect your Postgres installation, try to get a consultant to help you set it up. Don't just play around with it yourself. I know it sounds stupid to get a consultant for those things, but believe me, that is money well invested. You get to a good point like much faster with much less problems. You not over configure Postgres. The worst problem is that if everything seems to work out and you get like super fast response times and stuff, but when you actually put load on the system, you have it over configured, you run out of memory. Stuff like that is not nice. So make sure you have somebody who understands that. And the other thing is Postgres loves used pages. So wherever you run Postgres, make sure you have huge pages enabled in your kernel settings, blah, blah, blah. With Kubernetes, there is like a little bit of an issue, and we'll get back to that later on. Just remember, huge pages are great. And because we're in the Postgres ecosystem, much more knowledgeable people than me actually wrote about that before or even recorded a video. Make sure that you actually listen to them. They give you a lot of information about how Postgres should be configured for performance, how you set up the huge pages in Postgres and stuff like that. The slides are shared, as I said before. So just follow the links afterwards and you're in for a good read. Then you have Postgres extensions. And that is where it becomes a little bit more complicated. You remember when I said that on hyperscaler setups, huge extensions might already be an issue if you have something like timescale. PG vector is very common these days to be seen on those setups. But in the first couple of months, PG vector was still an issue, right? So the second you use extensions, you might be out of the scope of hosted setups. The problem is you might not be out of the scope in the sense of when it comes to Kubernetes, right? So the standard image for Postgres does not contain a lot of extensions. And to my surprise, I think the standard image doesn't even support PostJS, which I find very confusing, but it is what it is. That means the second you need extensions, you actually need to build your own layers, like image layers, Docker image layers on top of the standard image. I would always start from the standard Postgres, like the official Postgres image, and then just keep adding and installing the extensions. The alternative is that there is some magic, and we'll get to that later on in the presentation, magic that I really the other thing that I find very important is to keep an eye on your versions. We all know that Postgres versions can be complicated, especially when you do major upgrades and you have to run something like pgmigrate. That is always an issue because you have to have both Postgres versions. The version you're running on right now and the version you want to go to, PG15 and PG17. That is true when the data file format actually changed and you have to run a migration. For those kinds of things, there's two things to consider. As I said, first of all, you need both versions of Postgres in your image. And secondly, you need double the storage because that is not an in-place update. It's actually a copy operation. So it copies the database in the new format to a different location. Keep that in mind because for a while it will actually double your storage requirements. And for Kubernetes versions, it's the same thing. It can be complicated. If you use like a hosted managed Kubernetes, like AKS or EKS or whatever, they often only support like the last 3 or 4 versions. And I think Kubernetes provides a new version like every 3 months. After a year, you're out of support. AWS just recently started to provide extended Kubernetes support, which I think goes up to 5 or 6 versions. The second you switch from Kubernetes to extended Kubernetes, you're paying 10 times the price. So invest that money slightly better into somebody who can actually help you with the migration of Kubernetes. So that means at least once a year or something, around that time frame, you're in for a Kubernetes upgrade. Keep that in mind. If you run your own hosted Kubernetes, you can get around that. I would not recommend that. There's a lot of cool stuff that comes in new Kubernetes versions, especially related to storage. So I would try to keep them up and running as much as possible. All right. So now that we have all of that out of the way, and there were already some hints, what is really different? Where do we have to put our thoughts when running Postgres and Kubernetes? And the first and most important one is storage, right? We heard that people think storage will kill you because it's too slow. In Kubernetes, you have the idea of persistent volumes. And persistent volume is basically your virtual storage entity, your unit, whatever it is. It could be backed by NFS. It could be backed by local volumes. As I said, I think they're a bad idea. Don't do it. They could be backed by a remote storage. They could be backed by Amazon EBS or Cloud Disk or whatever. There's a lot of options how to get storage into Kubernetes. The good thing is Kubernetes for a couple of years now has the CSI interface, which is the CSI stands for Container Storage Interface. It was designed as a pluggable storage API for Kubernetes, but what it became is that it's now like a more standardized container interface. A lot of container runtime support it. Docker supports it. Containerd supports, CRI-O supports it. Not all providers support all backends. But I think that is just a matter of time. But for Kubernetes, CSI drivers are the way to go. Make sure your CSI driver supports encryption address, right? You remember, always encrypt stuff. Make sure you find something which is high IOPS. NFS might be out of the picture here. Go for SSD and NVMe, like this. You want something low latency because we know databases love fast storage. Postgres loves storage as fast as possible. So if you really want to do something, that's a great solution. Again, I might be biased, but I think disaggregated storage is the best way. Disaggregated means that you basically separate your storage from your application. I think this is the only meaningful thing because databases tend to grow more in data size than they tend to grow in compute power. Right? New queries might introduce a higher overhead for compute, especially stuff like reports and things. If you have something like that, especially running reports, I would recommend using a CSI provider that can take snapshots and clones and spin up a second database on the cloned data and run your report on that, throw it away afterwards. That would be my approach. But because there is so many CSI drivers already, I found about 150, and that is not all. There's way more out there. But because it is so complicated to figure out what I actually want, I built a while ago, I built like storage class info that lists all of the CSI drivers that I found and with the features I think they support. It's really hard to read the code because not all give you all the information in their documentation. So you basically look through every single source code and try to figure out what they actually support and what not. If you use something and you find an issue, please raise a bug report. It's a massive YAML file on GitHub. Raise an issue. Happy to fix it. But what it gives you is like the option to filter the CSI drivers by capabilities, by lifecycle, by access mode, stuff like that. So storage class info, CSI drivers is the way to go for you. The other thing is, and I hinted at that, containers. Containers have requests, limits, and quotas in Kubernetes that are different elements. They all kind of manage resources or available resource for your database. They're not necessarily easy to understand. And from my perspective, that is one of the things where you really have to wrap your head around. As I said, it's not easy. So there's a great beginner's guide by Kodamite. Read it, try to understand it. It was one of the things that took me the longest to really wrap my head around what is the difference between requests and limits, what are quotas. But in general, if you have a sizable database, just make sure, or I would actually recommend just running the database basically as the only thing on those specific nodes. We'll get back to that later, but that is something you really have to understand. When you're in the world, even for stuff like Docker, but with Docker, it's slightly different, right? Normally you use Docker on a single node. Kubernetes is all about clusters and multiple instances, so make sure you have that in your mind. And you remember pages, really enable huge pages for Postgres. And I said it's a little bit more complicated with Kubernetes because you actually have to configure it in the host operating system. So yeah, you have to go into the Kubernetes host, like the worker nodes itself, and say, yes, I want huge pages. Tell the kernel about it. And my recommendation is tell the kernel also that you want to have a certain amount of memory reserved for huge pages, because then the kernel at boot time will reserve a huge chunk of memory just for you, like a continuous chunk of memory. And that is what you want for huge pages. Huge pages are a great thing to minimize memory allocation overhead. The thing with Kubernetes is that you actually have to configure it basically 3 times. So you have to configure it in your host operating system. You have to tell in the deployment descriptor, in the resource descriptor, that this pod or this container specifically is supposed to use huge pages. So you get access to them because they basically have to be mapped into your container runtime or container environment. And tell Postgres that there's huge pages available, right? Great read from the Percona guys, people that are much more knowledgeable in running massive Postgres Kubernetes setups. So those are the guys to ask. Then there is high availability. And as I said, Kubernetes is all about clusters. So it's really something you want to look into. And I think it's important, right? Now that we have Kubernetes, the only meaningful thing is to run Postgres as a cluster. And I personally have massively good experience with Patroni. I think Patroni is awesome. I think it's also the most deployed, high availability and cluster manager. But there's also rep manager and PG out of failover and stuff like that. Just make sure you use the cluster manager. You want automatic failover. You want to have primary promotion, stuff like that. There's a great set of tools. I would always recommend just going with Patroni. The most interesting thing about Patroni for me specifically was that it is developed by Zalando. Zalando to me was a company selling shoes and clothes, right? Stuff like that. It was not necessarily like a high-tech company, but what I figured out is that basically all of the database setup at Zalando is Postgres. And so it makes sense we're pretty deep into the Postgres ecosystem. The other thing, and that is one of the things, again, that you can't really stress enough, connection pooling. I would claim never run Postgres without connection pooling at all. Connection pooling is basically a proxy in between your database and your application. And the reason you want that is because Postgres really doesn't like connections being opened and closed. Connection management is very expensive in Postgres. So using a connection pooler, keeping backend connections to the database open, while having the option to the front to give to the clients and say, hey, just do whatever you want, is removing a lot of overhead and resource utilization from Postgres, stuff that shouldn't really be in Postgres at all, right? The other thing is when you go into the cloud, especially when you go for like serverless environments and serverless infrastructures or application architectures, now it really becomes a thing, right? You're starting and stopping functions on a second basis. And now imagine, as I said, Postgres doesn't like connections being open and closed. But if you start your function and you close it down, you're opening a connection, you're closing it. At that point, you really want to go into connection pooling. So in general, if you don't use connection pooling now, or as of now, it's time to fix that. Schedule a maintenance for tomorrow. But there's a couple of more things. It actually, together with something like Patroni, connection poolers really nicely handle failovers. They handle the switching of primaries. Your application doesn't need to know about stuff. They often support like an internal retry. So if stuff fails for the first iteration, they just switch over and go back. All of that kind of stuff is really nice. And only give you like the error afterwards. But on the other hand, it also handles the read replica setup. If you have read replicas and you say, okay, I want to use those as actual query targets, all of those tools support reading from read replicas. I personally prefer, and I know it's controversial, PG Pool 2, but there's also PG Bouncer. Just make sure not everything that looks like a read-only query, like a select query, might actually be non-mutating. With timescale, we have create hyper table, which is a mutating operation, but because it's a function, it's called by select. So sometimes you have to tell those proxies, hey, those are operations or those are queries we specifically want to send to the primary for write operations. Then you have Kubernetes features, where in Kubernetes, so use stateful sets, use replica sets, all that kind of stuff. Interesting enough, Timescale just a week or two ago promoted or released a blog post about how they removed stateful set with a new abstraction, because stateful sets are very limited in what they can do. So go and read that one. You can find it on the Timescale blog. You really want to see that. Then network policies, you remember, right? Use network policies, that there's TLS, enable it as much as possible. Use security policies. If your setup has role-based access control, that's something you really want to set up as well. Think about policy managers. There's OPA, the Open Policy Agent. There's Kuverno. Be careful with those. I would recommend thinking about those. They're basically sitting in between like your API client and the Kubernetes API, and they can prevent stuff like, hey, there's some container that wants to mount a volume, but it's not one of the database containers. So you really want to prevent that, right? You don't want to have potentially arbitrarily injected container mounting your database volume. The only problem is, I heard that at least about Kuverno, you want to be careful. Kuverno has the default of preventing all access, or blocking all access, which sounds meaningful. But at least for that person, the Kuverno containers itself died and they couldn't restore it because Kuverno didn't have access to the Kuverno APIs or to the Kubernetes APIs anymore. So there can be problems. Be careful. Then there is observability, and I think, or alerting. Make sure that you have a good monitoring observability tool in place. Unfortunately for Postgres, Prometheus is still the best thing we have. I hope that this will change in the future, but it does an okay job. Collect logs, make sure that your logs are actually more than, I don't know, like a gigabyte or the last 10,000 entries or stuff like that. If you have an issue, 10,000 lines of log messages might be over really fast, right? So use one of the tools, the typical log collection tools, aggregate, analyze, trace. I would always go for full observability. You remember I work for Instana. And observability basically gives you an insight into the whole stack from front to back. That means don't roll your own. You might have figured I'm not a big fan of rolling your own stuff. Use a tool like Datadog. I'm not sure about Instana as it was acquired by IBM. These days, most of the development goes to IBM technology. But there's other things. There's Dynatrace, there's New Relic, there's Grafana, there's I don't know what else. Use one of those tools. You're in for a good game. And then is the point where all of that comes together, right? Like the little bit of, okay, here we are. With Postgres, we have to configure a lot of stuff. We need to make sure that we have high availability. We need to make sure that our backups are set up. We need automatic failover. We don't need all that kind of stuff. And while Helm charts are okay, they are a static setup system, right? So Helm charts help you with the initial static deployment. They don't help you with the day-by-day operation setup. And that is where operators in general come in, Kubernetes operators, in this case specifically Postgres Kubernetes operators. They take away a lot of the tasks for setup. They make sure that everything runs. They make sure that you can scale out, scale in. They bring this like feeling of cloud natives to Postgres, whereas that's a little bit of a far-fetched thing, and we see that in the last slide. But it integrates Postgres really nice with Kubernetes, where that is also depending on the operator. So there is a few operators, and that's not all of them. But I think those are like the big ones. If you're in for a very old version like 9.6, there's no way around QDB. The other ones don't even support that anymore. Zalando, again, from my perspective, Cloud Native PG and StackRes from Ongres are the ways to go. Those are like the big newcomers or upcomers from my perspective. We see that all the standard features are all supported. Where it falls apart a little bit is backups. And that is something I really find confusing. We're all about automation in Kubernetes, but Crunchy and Zalando don't really support Kubernetes, backups, which are nicely integrating into Kubernetes. I think that's an oversight. It might be fixed in the future, but it's confusing. The other thing that I think is important that they use a default Postgres image, like the official standard image. Cloud Native PG doesn't actually do this. So I'm a little bit confused about that. You see that StackRes is the only one that has all the check marks. If you really need a web UI, I think that's up to you or to decide. But as I said, Cloud Native PG, StackRes, both are great solutions. Both are great options. Absolutely nothing to say anything against them. The only thing, StackRes has like a cool feature. You remember the magic for image layers? They actually have a virtual image repository where they take the standard image and then you say, hey, I want this extension and this extension. They spin up virtual image layers with the extension code on the fly. And that even works at runtime. You can say, hey, I want this, and it magically appears in your image and you can just load it. But again, there's more people that actually wrote about that. In this case, I actually wrote the first one, but there's Operator Hub, anything Kubernetes operators, that's your first way to go. And the Data on Kubernetes community created a massive Postgres specification, operator specification with all features for Postgres and operators and how they're supported. And I think there's over 30 Postgres operators in there. So you really want to look into that. It doesn't have a nice UI yet, but we're working on that. So the last thing, when you have a meaningful size database, so anything that needs to scale, make sure that you use dedicated machines for your databases. Use node pools, dedicate a certain set of nodes or dedicate a node pool to your database, to your primary and your read replicas. Make sure that those containers or the database containers are pinned to those hosts, taint the hosts so that nothing else is running at it except like the standard Kubernetes services like kubeproxy and stuff. But that's about it, right? Make sure your database has basically all the resources and use Kubernetes for automation, for orchestration, not for virtualization in the sense of over provisioning. I think your database still deserves as much resources as possible. So with that, I think we're at the end. A lot of you might know Kelsey Hightower. I normally say when Kelsey speaks, the world listens. And Kelsey had a few things to say about Postgres or databases on Kubernetes, which is you can run a database on Kubernetes because it's fundamentally the same as running a database on a VM. Okay, so far so good. We can do that. The biggest challenge is to understand that rubbing Kubernetes on Postgres won't magically turn it into Cloud SQL. So what he's saying is, just because Postgres now runs on Kubernetes, it doesn't mean it gives you this proclaimed infinite scalability of something like Cloud SQL or Aurora or stuff like that. You're getting close and you can scale out with the necessary correct storage underneath. You can get very far. But I also say most people or most companies probably don't need something like Cloud SQL. It's a very overhyped, unnecessary thing from my perspective. It makes stuff easy to get started. I would claim this is not where we need to go. Anyway, the data on Kubernetes community is anything data stateful workloads on Kubernetes. It's mostly like a lot of the people that initially started implementing stateful workloads on Kubernetes and the stateful set and stuff like that. They eventually joined together in the Doc community. They wrote an amazing white paper on data on Kubernetes. Read it, go with that. And that said, thank you very much.